Folks, welcome back to my channel. In today's tutorial, we shall be taking a look at the trigonometric question on the board. Something very simple and exciting. So let us look at the problem together and the solution as always. We have here that if tan x equal to half, find the possible values for tan half of x. As you can see, the tan half of x is the head start on where we are to start. That means that we are going to use the addition formula for compound angles. Then we now break it down for half angles. So folks, before we delve into the solution proper, if you are new on this channel or today is your first time of watching our video on YouTube, please do well to subscribe and smash that bell notification so that you can be notified anytime I upload a new video. Without any further ado, let's get back into the video. So here, like I said, you look at the question very well, and what we are looking for is actually a direction. We have tan x, and we are looking for tangent of half of x. So I can write that the tangent of angle s can be split into the tangent of half of x plus half of s. So this is the main cross in this solution. So from the addition formula for compound angles, we have that the tangent of angles A plus B can be written as the tangent of angle A plus the tangent of angle B upon 1 minus the tangent of angle A multiplied by angle B. So we're going to apply this formula for this, So hence the tangent of half of x plus half of x can then be written as the tangent of half of x. Here, please don't get confused here. So if the tangent of two angles A plus B is equal to this formula, tangent of angle A plus the tangent of angle B, everything upon 1 minus tangent of angle A multiplied tangent of angle B. So if you are then to express the tangent of half of x plus half of x, it means that half of x is A or tan A. No, that's wrong. A is half of x and B is half of x. A is half of x and B is half of x. So tan A will now be tan of half of x. Tan B will also be tan of half of x upon 1 minus the tan of half of x multiply the tan of half of x. So we are going to have. But from the main problem, the tangent of angle x is equal to half. And angle x is half of x plus another half of x. So we can then write that the tangent of half of x plus the tangent of half of x upon 1 minus the tangent of angle half of x multiply the tangent of angle half of x, everything equal to 1 upon 2. If you look at what we have here, it's very easy to understand. The tangent of x is equal to the tangent of half of x plus another half of x. Now, the tangent of x is half, and x is represented by these two angles, half of x and half of x. So this is valid. On the numerator, the tangent of angle half of x plus the tangent of angle half of x. Tangent of angle half of x plus the tangent of angle half of x. That's going to be 2 the tangent of angle half of x. Then on the denominator, the tangent of half of x multiply the tangent of half of x. That will be tan squared half of x. I'll write 1 minus tan squared half of x. Everything equal to 1 all over 2. The next thing is to cross multiply. So I'll cross multiply this diagonal first. That will be 1 minus 1 multiply this entire expression of the denominator. It remains the same. Tangent square half of x. To multiply this expression, we'll be having 4 tangent of half of x. Okay, because of the square term here, we are going to have a quadratic equation. So I will take 4 times half of x to the left. After crosses, the equality sign becomes negative. 1 minus the tangent of squared half of x. Tangent square half of x. Sorry for that. The tangent square half of x minus 4 tangent half of x. Everything equal to 0. Okay, the square term first, followed by the linear term, followed by the constant term. So this becomes minus tan squared half of x minus 4 tan half of x plus 1 equal to 0. In a quadratic equation, the leading coefficient is always positive. It's more like a tradition. So I will multiply every term on this equation by -1. Here I will have negative multiply negative. That will be positive. Here the same thing. Here we now have negative equal to 0. So at this level, I'll make a substitution. I'll say let y equal to tan half of x. So if y is equal to tan half of x, we can write this to be y squared plus 4y minus 1 equal to 0. So this is the equation we are going to solve. And at the end of the day, we'll do backward substitution. Okay, so here, already the coefficient are a equal to 1, b equal to 4, c equal to -1. We cannot actually factorize this. We are going to use the formula method. So y equal to negative b plus or minus b square root of b square minus 4ac upon 2a is the quadratic equation formula. A is equal to 1, b is equal to 4, and c is equal to -1. So y will be -4 plus or minus square root of 4 squared minus 4 multiply 1 multiply -1. That will be -4. Everything upon 2 times 1. Okay, we move again. It's simple. Y will be -4 plus or minus. Here we have 4 squared, which is 16. Negative, that's positive. That will be 16 plus 4 all over 2. So y will be -4 plus or minus square root of 20 upon 2. So this is an examination question. So we are going to express 20, as a radical. So the same thing as -4 plus or minus square root of 4 multiply the square root of 5, everything upon 2. And the square root of 4 is 2. Square root of 5 is irrational. That will be rad 5. So therefore, y equal to -4 plus minus 2 rad 5 upon 2. Okay? The first answer will be y1 equal to -4 plus 2 rad 5 upon 2. Okay, I think I can even excuse that one here. Y2 will be negative 4 minus 2 rad 5 upon 2. So 2 can divide everything on the numerator. So we have y1 equal to negative 2 plus rad 5, or we have y2 equal to negative 2 negative rad 5. I can write this to be y1 equal to rad 5 minus 2, or y2 equal to negative rad 5 minus negative 2. And we made a substitution at the beginning, and we said that x equal to, okay, y equal to tan x upon 2. Y equal to tan of x upon 2. So we can then say that the tangent of half of x will now be rad 5 minus 2, or negative rad 5 minus 2. So this is the solution to this problem. Thanks for watching. Please give this video a thumbs up, share with your learning friends and colleagues, and don't forget to put your comments. See you next time. Bye.